So once you've downloaded the uh, MotorDoc energy calculator, it'll download as a zip file, save it to an area on your computer. For this case, I'm just going to put it on the desktop. And then you want to unzip it. So you want to unzip it by extracting, and we'll extract it to the desktop as well. So here we go. We are on the desktop and we have our folder. So if I go back to the desktop, you can see that a folder has been created. So if I go into this folder, double click it. I should have already, there we go. Okay, if this shows up, that's just normal. Yes, you want to go ahead and run it. This was developed in MATLAB. So if you do not have MATLAB runtime 2020 on your computer, it will download that as well. So here we go. We're going to add a shortcut to the desktop, and I already have it installed. Otherwise, it's a 600 megabyte. You'll want this because I'm going to do a series of additional calculators, and they'll all run on that engine. So there we go. And there it goes. It should not take too long to install if you already have the runtime on there. And we have completed the installation. Now for the next step, we'll be running it. So let's go ahead and get rid of these now. I'm going to go ahead and run the software. Now it's going to link up with the MATLAB runtime library. So it may take a second to start up. This is a rather loaded computer as well, so things take a few seconds. And I'll quickly go through what you can do with this neat little toy. Okay, so here is the energy calculator. So there's no print on this or anything else at this point in time. There's this is part of a larger system that I'm developing that will actually pull data for regen and everything else for emissions, and allow for variable loads, including importing maps of variable loads and so on. So for this, I can do a number of things. One, I could just put in a beginning kilowatts and any information on this side. It'll fill in just the areas that are of interest over here on the right. So if I say, okay, I want to know what my 100 kilowatt operating load machine is at, say, $10 per kilowatt demand, and just for ease, we'll say 10 cents per kilowatt hour usage, and I'm operating, say, 6,000 hours per year. I can calculate that, and that's going to give me my costs over here. So the negative numbers down here mean there's no savings, so that's what you end up with. Now if I say, okay, I'm going to correct it down to 96 kilowatts, everything else remains the same. This will come in and I'll show that I'm saving 17 tons of CO2. This is for US, based on 2020 data that's available off the Energy Information Administration, so 0.707 megawatt hours per ton, or tons per megawatt hour. Up here it'll show the savings. Now I can go one more step and say, to get that, it cost me $2,000. And when I calculate it again, I've got about 0.7 years return on investment, or simple payback, I should say, not return on investment, but simple payback. Here's the savings, here's the energy savings. Now if I have a different application that I'm interested in, I can screen capture this and include it in a report. I can do whatever I want here. Reset brings it all back to zero, and by the way, X closes it. I can make it full screen, but it just looks uglier, that kind of thing. But let's say I'm doing an empath analysis. So on the empath analysis, I say that I have bearing losses measured totaling 1.8 kilowatts. This is the beginning of an issue, and if I correct it, it will, go to zero. But let's say I just say, okay, in the end, I'm going to estimate that because I'm going to add lubrication, I might drop that to zero point 0.5 kilowatts. I put in that same number, different region, so we'll say 7 cents per kilowatt hour. Operating hours, only 4,000 hours. Adding the grease is going to cost me $50. Then I can calculate it, and just reducing just that friction on just that bearing reduces my emissions by 3.7 tons. It saves me $520 per year. So driving through a failing bearing actually has a cost. This is why we're also going to put in the variable loading, because the bearing is, of course, going to degrade over time. I'll have calculators specific to that by this summer that will show the average degradation of a bearing over time based on the application and environmental conditions. That's part of a larger project, like I said. And if you're a newsletter listener or listen to one of my podcasts, you get access to all this cool stuff. So I'll have these calculators available as I develop them. It's basically taking all the work I've done over years, and we're going in and we're putting it all as part of machine learning. So with that, thank you very much, and enjoy. Please provide any feedback to info@motordoc.com. Things and features you'd like to see. For those overseas, because when I put this out on LinkedIn, everybody got excited. I may put in another area so you can put in your own CO2 emissions with a default to the US. That will be in the next edition.